to lie. Still beneath the hush of a nighttime sky, where stars whisper above you like distant campfires, this is where the story begins, not with rockets roaring into the dark, but with a quieter question. What if we could travel the stars not by force, but by surrender? Close your eyes. You're floating now, not in a ship, not in a suit, but in a moment, suspended between now and the next century. A soft current carries you outward, like a thought escaping gravity. The earth falls away behind you, blue and brave, and the stars grow larger in your mind than they ever seemed through a telescope. This is a dream, but it is not only a dream. For generations, star travel was poetry first, the domain of myth and marvel. From Daedalus to Deep Space Nine, we've sculpted ships in stories, sailing not through oceans, but through time and curiosity. But now, gently science joins the dream, not to tame it, but to walk beside it. And at the heart of this new frontier lies a paradoxical companion: destruction as propulsion. The most beautiful engines we've never built antimatter drives. You drift through the concept like mist. Antimatter, the mirror of all that is. For every electron, an opposite, the positron. For every proton, an antiproton. They are not evil twins, just equal ones, born with a destiny to meet their other half and vanish. But in that vanishing, oh what fire! When matter meets antimatter, there is no leftover, no smoke, no ash, no remains, only pure energy, released in a perfect burst more powerful, per gram, than any chemical or nuclear reaction humanity has ever known. It is the whisper of annihilation, and yet in that whisper, the dream of propulsion stirs. You imagine now a spacecraft, its long hull catching the faint sunlight between stars, its heart beating not with fuel, but with balance, carefully mixing tiny specks of matter and antimatter, turning disappearance into motion. It's not a loud burn, but a quiet symphony of precision, a dance of particles choreographed to push, to glide, to slip free from the leash of planets. You float beside this imagined ship, its antimatter core glowing gently in the dark, not with flame but with promise. Yet, you wonder, why haven't we built such dreams already? Why does the sky above still hold only satellites and sighs? Because antimatter is not a gift freely given, it is rare, breathtakingly so. The universe, for reasons still cloaked in cosmic mystery, chose matter as its melody. Antimatter is the harmony that rarely plays. To make it, we use giant machines, particle accelerators that bend light into loops and fling atoms at each other like tiny comets. Out of the chaos, antimatter is born, but only for a moment. Touching even the walls of its container, it vanishes. It must be held by magnetism, trapped in invisible fields, never allowed to rest. So fragile, so fleeting, and yet possible. You're drifting through a lab now on the edge of midnight. Physicists whisper across control panels, watching delicate clouds of antihydrogen float in perfect balance. Each one a miniature starship seed. Not fiction, not yet flight, but real. The math is done in silence, the dreams are drawn in blueprints, and still the fuel remains more precious than gold, a gram worth billions. But then your mind turns to scale, to stars, to centuries. In this slow voyage of the mind, you recall the stars nearest to Earth, Proxima Centauri, a mere 2 light years away, in spaceship years in eternity. But with antimatter propulsion, we begin to compress time, not erase it, but soften it. A spacecraft, fueled by milligrams of stored annihilation, could coast between stars in decades, not millennia. Still not fast, but faster than any ship we've built. And more than that, it's the kind of travel that invites patience, that hums rather than shouts. You breathe slower now, as if matching the rhythm of a journey not yet made, and then comes a thought that slips like a stone into still water. If antimatter holds such promise, what are we waiting for? The answer is layered, like the rings of Saturn: fear, funding, friction, but mostly time. We stand at the doorway of the antimatter age, not because we are unwilling, but because we are unfolding. Like the petals of a slow-blooming flower, technology must stretch gently toward readiness, and still it blooms. You see now not just ships but societies shaped by such travel, not astronauts racing through space, but thinkers sailing gently through the interstellar dark, carried by craft that hum with annihilation, but leave no scar. The stars are no longer distant fires, but neighbors distant still but imaginable. And in that imagining, you return to your own breath. Here, now. A body in bed, but a mind still wandering the stars. You began this journey with a whisper, and now the whisper becomes a question. If annihilation can be turned into motion, what else might we learn to transform? Tonight you dreamed of propulsion born from vanishing. In the next chapter you will follow where that motion leads not just outward, but onward, toward the strange music of deep time, and the places where energy becomes memory. You float now in a space not filled with stars, but with echoes, soft invisible twins whispering through the void. For every particle you know, there is another not opposite in hostility, but in grace. A mirror held up by the laws of nature reflects not just light, but being. Imagine this: a perfect marble, round and smooth, gliding over glass. Now imagine another just as smooth, just as round, but where one curves left, the other bends right. They roll side by side, never colliding, always complementing. These are matter and antimatter, the dancers of symmetry. You follow an electron, small, negative, spinning like a dream through the dark. It hums softly, a lullaby of charge. And then, across an invisible curtain, you see its twin, the positron. It is not its enemy, it is its partner. The positron carries the same mass, the same restless spin, but with a charge reversed positive instead of negative. Together, they are a whisper of balance, and this balance is not rare. It is written into the very equations of the cosmos. For every type of particle, electrons, protons, quarks, there is an antiparticle, mirrored and opposed, like left and right hands. Not evil and good, not dark and light, just reflections. In the early moments of the universe, these pairs were born together side by side, matched perfectly in number and energy, matter, antimatter. It could have remained this way, the universe a sea of perfect cancellations, where every meeting of a particle and its twin would end in a quiet flare of light, energy released in a gentle sigh, because that's what happens when they touch. They disappear. Not in violence, but in transformation. A particle meets its antiparticle, and in a moment of profound intimacy, they vanish, their mass converted into pure energy, a quiet burst that fades back into the cosmos. It is like watching two notes on a piano strike at once, cancelling their sound into silence, leaving only the memory of the melody behind. But here's the mystery: you feel like a cool breeze against your skin. If the universe began with equal parts matter and antimatter, why is there now so much more matter than antimatter? Why are you here at all? It's as though the mirror shattered, just slightly, as though in the opening breath of time, for every billion antimatter particles, there were 1,000,000,001 of matter. That single surplus, that quiet imbalance is everything. You are that imbalance, every star, every planet, every breath you take, born from that one extra particle, left behind after the rest dissolved in light. The antimatter is gone now, mostly. We can only make it in the lab in careful cold machines where energy becomes form. Scientists coax positrons into being and trap them in magnetic bottles, like butterflies of opposite charge. They last only seconds, but they confirm the symmetry. And yet, in distant galaxies, in high-energy collisions, and the hearts of exploding stars, antimatter still flickers into existence. The universe remembers its other face. In rare moments you might even see it in a PET scan, where positrons, briefly alive, help trace the patterns of the living body. You drift through this symmetry, feeling not opposition, but echo. Antimatter is not against matter, it is with it, step for step, like a twin born into another world. In a gentler cosmos, the two might have coexisted, constantly meeting, constantly transforming into radiant light. A universe not of form, but of energy, beautiful, but empty. Instead, a stranger symmetry took hold. Perhaps it was a twist in a cosmic rule, or the whisper of a hidden particle still unknown? Maybe, deep beneath all we understand, there is a bias in nature's mirror, a slight tilt, just enough to let matter remain, enough to let you remain. You think now of reflection, of looking into a pool and seeing yourself reversed. Your left becomes right, your smile a question. That's what antimatter is, not the other, but the same in reverse. It reminds you that the universe does not favor one over the other. It simply is balance, tipped by chance, and this balance, this almost perfect symmetry, reminds us of what the cosmos could have been. A silent ocean of light, where all things cancel, but instead by a fraction, a sliver, a breath the mirror cracked, and something remained. You, and so you drift between the twins, between particle and antiparticle, matter and antimatter, not as enemies, but as dancers in a cosmic waltz. You imagine the elegance of their meeting, a soft contact, a glow, then nothing. The dance ends, the floor empties, and light hums in the silence. Now, you're left with a feeling not of absence, but of potential. What else hides in the mirrors of the universe? What other pairs remain unseen? What secrets lie in the symmetry? You close your eyes, and the question settles gently in your thoughts. If every particle has a twin, does the universe itself have a mirror? You close your eyes and drift backward. Not through memories, or even through time as you know it, but through something deeper. The hush between seconds. The space before the first tick. And then, quietly, you arrive at the beginning. The very first second. A moment when there were no stars, no galaxies, no atoms, only the wild, luminous roar of a newborn universe. You are here, in that instant. Not standing, not floating, just being. As if your awareness has melted into the fabric of creation. The Big Bang is not an explosion. It is an unfolding. A bloom of space and time expanding outward, like ink diffusing in warm water, or a breath exhaled into infinite stillness. In that breath, something extraordinary happens. Pairs of particles are born in shimmering balance. For every particle of matter, a proton, an electron, its mirror twin appears. Antimatter, antiprotons, positrons, identical in mass, opposite in charge, partners in a cosmic dance. They emerge from the energy of the moment, like sparks flickering up from a fire. They live briefly, then meet again and vanish in a kiss of light. Matter and antimatter, annihilating into pure energy. A pulse, a flicker, a whisper gone. And yet, somehow impossibly, you are here, not as light, not as energy, but as matter. A mind inside a body, built from atoms that did not disappear. So where is your opposite? The silence answers. This is the mystery. The universe, in its perfect symmetry, should have erased itself. Equal parts matter and antimatter cancelled out. Nothing left but light. But something tipped the scales. One extra particle of matter, for every billion, just enough to survive the annihilation. Just enough to become stars, planets. You, that sliver of imbalance, that single breath of excess is why you exist. But why did it happen? You drift through theories like clouds. Some whisper of subtle asymmetries, a quantum preference for matter, woven into the laws of physics like a bias in the loom. Others suggest ancient fields that broke the symmetry, like a cracked mirror distorting reflection. Still others hint at the unknown new particles, new forces, hidden hands you've yet to see. You imagine the universe as a seesaw, perfectly balanced, until some tiny nudge, a grain of sand, a breath tilted everything toward matter. And in that tipping, the world you know was born, but it could have been different. In another universe, the imbalance went the other way. Antimatter won. And if it had, would you be you? Would minds still wonder? Would eyes still gaze at stars? You listen to the silence again. It's not empty. It hums with the memory of what might have been. The ghosts of opposites, not chosen. In the quiet, you imagine meeting your mirror, your antimatter twin. They look like you, move like you, think like you, but touch them, and you both vanish. A burst of light, a reunion of opposites. It is a reminder. You are made of leftovers, a rare residue of creation. The survivors of a great cancellation, And yet, in those leftovers, stars are born, galaxies form, life emerges from imbalance harmony, from asymmetry meaning. You feel a warmth in that thought, that the universe did not need to be perfect to become beautiful. It only needed to be just enough. And so you lie there, listening to the quiet after the storm. The absence of antimatter is not a void, but a question that echoes in every cell of you. Why this? Why not the other? You exhale. The mystery lingers like a fading chord, and as the early universe continues to cool, its fire dimming into darkness, you begin to sense something new stirring. From the ash of that brief, brilliant imbalance, a different kind of light is about to emerge, not from particles colliding, but from particles joining. A moment of stillness before the next miracle. Atoms, bonding in the cold. The air is cool and dry, scented faintly with metal and quiet intention. You are deep underground now, farther than any city subway, deeper than the roots of trees. Around you the walls hum with energy not heard but felt. A silent thrum like a great mechanical heart beating in anticipation. This is the home of the particle accelerator, a vast ring beneath the earth, curving gently away into the darkness. It is not a place made for comfort, but for curiosity, for questions whispered into the void and the long, slow answers that come humming back in light. You walk slowly beside the loop, your footsteps muffled by concrete and dust. Overhead, thick cables twist like vines, pulsing with electric purpose. Along the wall, rows of copper coils and cooling pipes glint like sleeping machinery. Yet everything feels awake, waiting, as if the building itself knows that something extraordinary is always just about to happen. And then, with a sudden stillness, you realize this is where antimatter is made. It doesn't come easily, it doesn't come often, but here in this humming ring, human hands have learned to tease the universe apart. Just for a moment. Just enough to glimpse what usually stays hidden. You pass a quiet control room. Inside, scientists sit at curved desks, their faces lit by blue screens and blinking graphs. You cannot hear them, but you sense their focus. They are watching, waiting, calculating the impossible. Then the beams are fired. Particles, the smallest kind imaginable, are launched like arrows through the tunnel. Not just one or two, but clouds of them bundled into tight, roaring pulses. They travel fast, faster than anything you've ever felt, whipped around the circular path by powerful magnets over and over, again and again, until they collide. And in that instant, that single blink of energy and dust, something astonishing happens. A mirror particle is born. Antimatter. Where matter builds the world, you know, mountains and music and morning sunlight. Antimatter is its perfect opposite. If matter is a spark, antimatter is its shadow. And when the two meet, they cancel each other out, disappearing into pure light. Here in the accelerator, these opposites are made particles and antiparticles, sprung into existence in matching pairs. But like catching a snowflake on a sunlit stone, they vanish almost as quickly as they appear. Unless someone is ready. You follow the trail of quiet light to a different room, darker, cooler, filled with strange machines. Here scientists have learned how to catch antimatter, not with nets or boxes or heavy glass jars, but with invisible cages, magnetic traps. You imagine it like this, a field of soft light forming a bowl of force, keeping the delicate particles from touching anything solid, for even a whisper of matter would destroy them instantly. They are held, suspended, floating like fireflies in jars that are never touched. It's almost poetic, this gentle balancing act. You lean closer, peering into the chamber. There in the vacuumed dark, a few ghostly sparks hover, antiprotons maybe, or positrons, the mirror of electrons. They seem to glow faintly in your imagination, like stars that forgot their way home. And you wonder, how is it that something so powerful can also be so fragile? The scientists you sense are used to this mystery. They do not fear it, they do not try to tame it. Instead they ask questions endlessly. How long can we keep them? How cold must the trap be? Can we study their fall, their spin, their light? They are listening to antimatter the way one might listen to an unfamiliar instrument, a cello made of silence and heat, vibrating just beyond reach. For most of the universe, antimatter is a ghost. When the cosmos was new, fresh, and expanding like breath on a cold mirror, matter and antimatter were created together, perfectly balanced. For every particle of something there was its twin, a not something poised to meet and vanish in light. But somehow, impossibly, matter won. A tiny imbalance, just one part in a billion, tipped the scale. And everything you see, your hands, your thoughts, the air you breathe, was born from that tiny leftover. So why did matter survive? No one knows for sure. That is why, in this underground chamber, scientists send particles crashing together again and again, hoping the echoes will whisper back answers. They are rewinding time, pressing their ears to the quiet beginning of things, looking for the moment where the symmetry broke, and maybe one day they'll find it. You close your eyes for a moment, letting the hum of the accelerator wash over you. It is not a place of noise but of motion, of silent storms and invisible waves, of particles leaping from existence into disappearance in the space of a heartbeat. Yet there is something comforting in that, a rhythm to the vanishing, a pattern to the disappearance, like the breath of the universe, inhaling and exhaling the same mysteries again and again. You open your eyes and glance again at the firefly particles in their magnetic cages, still glowing, still fragile, still there. A reminder that even the most impossible things can be held if only for a moment. You turn to leave, but something in you lingers. Not just for the science, though that is wondrous, not just for the glow of rare particles caught in midair, but for what it means to try, to build a trap for what cannot be touched, to measure what cannot be seen, to understand what, by its very nature, is always just out of reach. And as you rise back to the surface, from metal to earth to open sky, the question follows you gently, like the tale of a dream. If antimatter can be made and held and studied, then where in this wide and ancient universe might it naturally still exist? You drift gently now, weightless in thought, wrapped in the hush of cosmic possibility. All around you, the universe whispers, not in roaring explosions, but in delicate balances. Matter and its mirror, antimatter. Imagine a single speck, so small you could fit it on the tip of an eyelash. A positron, the antimatter twin of an electron. It hums with energy, a quiet pulse of potential, waiting for a reason to exist. In the vastness of space, this tiny presence is rarer than gold, rarer than any jewel. But oh, how powerful! You float beside the numbers. Not equations this time, but budgets, timelines, the raw costs of dreaming to make a microgram of antimatter. Scientists work for years. Each positron, each antiproton, coaxed from high-energy collisions inside giant machines, particle accelerators, humming deep beneath Earth's surface. It takes billions of dollars, colossal magnets, and entire teams of minds tuned toward the tiniest things imaginable. For every grain of stardust they make, thousands of atoms vanish in the search. It's like trying to bottle lightning. You need to crash particles together with unimaginable speed. You gather what appears sometimes an antiproton, sometimes nothing at all, and then the hardest part, you have to hold it. Store it, because if even one tiny bit of antimatter touches regular matter, they vanish, annihilated. In a sudden bloom of pure energy. This isn't like storing batteries in your drawer or fuel in a tank. Antimatter must be suspended in magnetic traps floating in vacuum chambers like ghostly fireflies. No walls, no touch, only fields and patience. You feel the effort it takes in your breath. All that work, all that time, for a substance we can't even bottle properly yet. So why bother? The question hangs in the air, soft and persistent. You drift deeper into the story. The dream of antimatter has never just been about what we can do now. It's about what it might let us do someday. Antimatter is energy in its purest form. When matter and antimatter meet, They don't just burn, they disappear, and in doing so, release energy more potent, more concentrated than anything else we know. A single gram of antimatter, if we could ever create and control it, could unleash the same energy as a small nuclear bomb. But unlike a bomb, it doesn't need fission or fusion. There's no radioactive waste, no lingering residue, just light, heat, a perfect end and beginning. So scientists dream, not of weapons, but of propulsion, of journeys, of starships that could ride these reactions across the stars. Because the energy-to-mass ratio of antimatter is astonishing. A spacecraft powered by it could go farther, faster, perhaps fast enough to reach another star within a human lifetime, perhaps fast enough to leap beyond the solar system. You picture it now, your ship, quiet as thought, gliding on antimatter winds, no roaring engines, no fire, just momentum, harvested from the dance of opposites. But such a dream feels far, doesn't it? You return to Earth, where we've made less than a billionth of a gram of antimatter in total, where the cost of just 1 microgram would be measured in trillions of dollars, where even the best particle labs can only trap a few antiatoms at a time, and only for seconds. Still, we keep going, because to create antimatter is to do something profoundly difficult. It requires mastery over physics, engineering, patience and hope. It's not efficient, not yet. But it's a symbol of reaching beyond convenience into the realm of courage. You think of the scientists in CERN and Fermilab, tuning their machines like musicians, chasing particles with invisible hands. They're not just making antimatter, they're learning how to listen to the universe more closely. Each speck is a message. You are capable of wonder, and that wonder isn't limited to spaceships. Antimatter might hold answers here on Earth too. In medicine, for example, positrons are already used in PET scans, allowing us to peer into the living brain, the beating heart. Each time a doctor sees the invisible, antimatter is quietly at work. One day, maybe we'll find ways to harvest antimatter naturally in the magnetospheres of planets, or the belts of high-energy particles around neutron stars. Perhaps the universe already holds reserves of what we struggle to create, tucked in cosmic corners, waiting to be gathered. So yes, it's expensive, impossibly so. And yes, it's slow. But that's the nature of reaching for things that almost don't exist. The process teaches us how to dream with precision. You float again, this time not in space, but through the long corridors of human thought. Each lab, each experiment, a light in the dark. Antimatter may never power your car, or light your home, but it might one day carry your grandchildren to the stars. And even if it doesn't, the search itself changes us. It refines our instruments, our thinking, our collective patience. It makes us more than what we were. You pause, watching the delicate dance of energy and emptiness. In your mind, an antimatter engine pulses, not yet real, but real enough to imagine. The cost is high, the journey is long. But isn't that true of every beautiful thing? You listen, quietly now, as the hum of curiosity continues. Somewhere ahead, another question forms, soft as starlight, sharp as science. You drift in the quiet dark, as if suspended in ink. Around you, space stretches without edge or flaw, the backdrop of all beginnings. In this gentle stillness, something stirs, not with a sound, but a thought. What if we could ride the very fabric of existence? What if, instead of fire and fuel, we moved with annihilation itself? Antimatter. The word feels heavy, like forbidden music. You taste it slowly, antimatter, and feel the symmetry click into place. For every particle of matter, there is an equal and opposite twin, its mirror, its shadow. Not evil, not wrong, just reversed. A proton and its antimatter twin, the antiproton, the same in mass, but opposite in charge. They cannot touch without dissolving in light. It's a fragile dance. If matter is the ink that writes the universe, antimatter is the invisible pen hovering just above the page. One flick, one contact, and the story explodes in brightness. You imagine holding both in your palms, one speck of matter, one speck of antimatter. They hover, tense, alive with energy. And as they meet, the world blinks. In that instant, everything becomes light. Not smoke, not fire, just pure energy, blooming outward with no waste, no remnants, no ash. A perfect conversion. Einstein smiles quietly in the corner of your mind, his equation unfolding like origami. E equals sign, mech with energy, equals mass, multiplied by the square of the speed of light. You float closer to the idea. Chemical fuel, like the rockets that brought us to the moon, burns only a sliver of its potential. Nuclear reactions dig deeper, breaking bonds inside atoms, fusing stars in their bellies. But even they leave behind fragments, leftover heat. Antimatter leaves nothing. In that brief embrace of opposites, there is no residue, only release. And what a release it is. You imagine a spacecraft, sleek and silver, not pushing through space, but gliding on beams of annihilation. Inside its core, a steady rhythm, droplets of antimatter, meeting their partners, vanishing into bursts of gamma rays and kinetic flame. Each collision more potent than thousands of tons of chemical propellant. A teaspoon of antimatter, just one, could lift cities, cross worlds. The engine hums, but not like a machine. It hums like a memory of something older than time. This is not fantasy, not entirely. In laboratories tucked inside mountain bunkers and wrapped in magnetic fields, scientists have already made it tiny, momentary specks of antimatter. Anti-hydrogen atoms, born in flashes and trapped for seconds, held away from the matter that would erase them. Expensive, delicate, and fleeting, yes, but real. The dream breathes. Still you wonder, why does the universe favor matter? At the Big Bang, matter and antimatter should have formed in equal measure, twin waves from a single splash. But look around, planets, people, poems, all built from matter. Antimatter is gone, or hiding. It's one of the quiet puzzles that physics carries like a locket. Somewhere long ago, symmetry was broken. And yet, that imbalance, that tiny tilt, allows you to exist, to float here now, to dream of engines not yet built. Back on your imagined spacecraft, you feel the pulse of motion, not as force, but as unfolding. You are not pushed, you are drawn. Each annihilation inside the engine carves a hole through inertia. It whispers, go, and the ship listens. There are no roaring flames, no towers of smoke. Just the soft unfolding of power, compact, clean, quiet. The silence is deeper than space. But there are challenges always. Antimatter touches matter, and they vanish. So you must keep them apart until the right moment. Magnetic bottles, like invisible gloves, must cradle the particles. They twist and spin in fields that hum with precision. Even the walls of your ship must be designed, not of metal, but of magnetic threads and carefully shaped vacuums, a dance of geometry and field lines. Then there's the question of creation. How do you make enough antimatter? Our current machines are slow, like drips from a stone. The cost of 1 gram is billions of dollars, and the effort, immense. But like all great engines, steam, electricity, fusion, it begins with curiosity and patience. What is expensive today may become abundant tomorrow. And dreams once thought impossible are the scaffolding of progress. You gaze into the dark again, this time not with fear, but with potential. Antimatter is not chaos, it is symmetry. It is not destruction, it is balance. You begin to see the engine not just as a tool, but as an idea, a way of seeing the universe. Every opposite has a partner. Every shadow, a light. Every silence, a sound waiting to unfold. And as you glide forward in your imaginary ship, powered by the cleanest fire the cosmos can offer, you wonder, where could it take you? To the outer rim of the solar system, to the nearest star, perhaps further, perhaps to places you haven't yet imagined. You feel the freedom of it, not fast, but continuous. A motion that does not need to pause, a voyage written in the ink of perfection. Somewhere behind you, Earth turns slowly in the dark. Ahead, the stars drift like ancient questions. You realize now that antimatter isn't just fuel, it's a metaphor. A reminder that even in destruction, there is grace, that opposites, when joined with care, can move mountains, or stars, or hearts. You take one last look at the antimatter engine, glowing soft, quiet, alive with balance. It hums with promise, not noise, with possibility, not pressure. And as your ship sails on, the stars ahead shimmer, not closer, not farther, just waiting. You close your eyes and glide gently forward. The stars do not move, but you feel yourself slipping between them as though the vacuum has grown silky, and your vessel is a whisper drifting through it. This is no ordinary journey. You are not aboard a ship powered by kerosene and flame. No, this ship hums with futures yet unlived. You float deeper into a quiet room, lit only by blue schematics, where engineers sketch not with pencils but with dreams. Every line they draw bends the fabric of reality slightly, like gravity itself responding to the weight of imagination. Here, engines are not just mechanisms, they are incantations. One design pulses with the logic of antimatter. It carries positrons like firewood in an old iron stove, tiny flecks of matter's twin, harvested, trapped and stored. When the positron meets its electron partner, they vanish in a burst of pure energy, from annihilation, thrust, from silence, motion. These are ships that ride on the clean fire of symmetry, undone. Another blueprint hums quietly beside it, etched in the language of magnetic nozzles and charged particles. This is the ion drive, gentle, persistent, patient. It doesn't roar, it whispers. Xenon atoms are coaxed into ions, then flung backward by invisible fields. The push is slight, like a hand brushing your shoulder in sleep, but the push never stops. Days pass, then months, and the ship, silent as a held breath, picks up speed faster and faster, until even starlight can no longer keep up. A slow sprint across the black, no fire, no noise, just momentum made holy. You drift toward another engine. This one is bolder, stranger, warm like candlelight behind the eyes. A solar sail impossibly thin, wide as a cathedral, light itself is its wind. Each photon, massless and bright, presses ever so gently against the sail's silken skin. And though the push is soft, so soft it is endless, no fuel to carry, just light and time, and hope. You wonder how such fragility could move something across the stars. But in space, power lies not in force but in persistence. A single breath, held for years, can carry a whisper between worlds. You float past a shape darker than the rest. This engine is not lit by fusion or flame, but by theory, still half myth, half possibility. The pulsing heart of it reads Alcubierre. Its blueprint curves in on itself, a bubble wrapped around a ship. Not motion through space, but motion of space itself. A warp, a fold, a gentle pocket of stretched time. You picture it, space contracting in front of you, expanding behind like swimming not through the sea, but pulling the sea itself past your body. It requires energy we don't yet know how to summon, perhaps more than exists in all the galaxies combined. And yet, the engineers dream it anyway. You admire their courage to draw what cannot yet be built, to whisper into equations and believe something might answer, to stare at stars and ask, what if we could just get there? You drift next to fusion engines, burning not with fire, but with the same light as stars. Inside these imaginary ships, tiny suns are born and caged, held by magnets shaped like prayer. Plasma swirls, deuterium and tritium embrace. And in their joining, energy flows, a light you could bottle and ride. These ships are not fast yet, their hearts beat heavy and hot, but they are still young, still theoretical. Yet you feel the warmth of their promise, not just propulsion but power. A way to light the dark, to feed a city on Mars, or keep a lonely astronaut warm during the endless night. And then your gaze lifts towards something even more delicate. Photonic drives, engines of pure light, no fuel, no matter, just focused beams of photons fired from enormous stations, orbiting suns, pushing wafer-thin crafts like leaves blown across the cosmos. These are the vessels that could reach another star within a lifetime. They will not carry humans, not yet, but they may carry our eyes, our questions, tiny cameras with wings of crystal and purpose, scouts on sails of light. You wonder what it would feel like to be one of those tiny ships, no larger than a fingernail, yet capable of riding a beam for 20 years toward Alpha Centauri, the second sun we dream of. Each design you pass feels like a lullaby. They do not shout, they do not rush, they are cradled in patience, in ambition tempered by the soft voice of physics, in belief that the universe allows us to try. You realize something here. These engines are not just about getting from A to B, they are about becoming, about transformation. They ask us to slow down, to wonder again, to imagine a future where movement is quiet, clean, and driven by the elegance of thought. Because space is not something to be conquered, it is something to be listened to, moved through like a forest at night, with reverence, with awe. And so you float, weightless among equations and possibilities, each one glowing softly in the dark, each one a promise, each one a story that hasn't been told yet. And as your ship of thought hums gently onward, you feel the silence deepen, not empty, but full, full of waiting, full of wonder, full of what might come next. A quiet shape appears in the distance, no longer a blueprint, but a structure, a world built, not imagined, artificial. Spinning, suspended between suns. What would it mean to build a home in space, not just to travel, but to stay? To live, not on planets, but inside orbiting ideas. You drift closer. The hum of engines fades, and the architecture begins to sing. You are floating now, in the hush of thought, weightless, quiet, held in the breath between understanding and awe. You are holding something in your palm, though it weighs nothing. It glows with imagined light. It pulses like a secret. You can't see it, not really, but you know it's there, a twin to all matter, built the same, yet reversed in the subtlest ways. This is antimatter. It is a kind of mirror, held up to the universe, a shimmering reflection where electrons become positrons and protons are born with negative charge. Everything about it feels familiar, but slightly askew, as if nature exhaled and caught its own shadow. You marvel at how symmetric the world could be, had matter not won the cosmic coin toss. In the beginning, truly, at the beginning, matter and antimatter were made in equal measure, perfectly paired, each particle with its anti spinning together in the primordial light, and yet somehow almost all the antimatter vanished. Where did it go? Why are you here, made of matter, not of its mirror? Physicists call it the asymmetry problem. You call it a quiet mystery. And now you cradle in your thoughts a single positron, the antimatter version of an electron. It exists. We've made them, caught them, even studied their dance with electrons under careful, hushed laboratory lights. When they meet, they vanish, not with a fizzle but a flash, a conversion of pure mass into energy, not smoke, not ash, just photons skipping away at light speed. That is what makes antimatter so dangerous and so wondrous. It is not poison, it is not fire, it is a different kind of power, the ultimate transformer. A single gram of antimatter, meeting 1 gram of matter, could release as much energy as a nuclear bomb. Hiroshima, flattened, with nothing but a breath of particles. One mistake, one misstep, and a city could vanish. And yet, we've learned to make antimatter, tiny amounts, nanograms, micrograms, created inside cyclotrons and particle accelerators, where protons are smashed and spun and sculpted into these rare twin shadows. But it takes energy, vast amounts, to make it, more than we ever get back. Antimatter is not yet fuel, it is a puzzle. Still your mind drifts to possibility. Could we one day store it, use it? Imagine a spacecraft driven not by combustion or solar sails, but by antimatter reactions, releasing energy cleanly, precisely, with no waste, only light. The stars might become reachable, we might build engines born of mirrored particles, but first we must learn to hold fire, and holding it, that is no small thing. You see, antimatter cannot touch matter, not even a whisper, so to store it we suspend it, in vacuum, with magnetic fields. in chambers colder than space itself. It hovers, imprisoned by invisibility, a particle that must never brush against the walls of its cage. The precision needed is not just technical, it is philosophical. Can we truly control the thing that undoes us? You imagine a future lab, quiet, circular, shielded deep beneath the earth. You walk its corridors, watching glowing data rise and fall like tides on digital shores. Inside a chamber, floating in magnetic embrace, rests an anti-hydrogen atom, a proton's shadow kissed by a positron. It turns gently, existing because we allow it to, protected by the trembling balance of force and field. You marvel again, we are beings who hold chaos at bay with equations and magnetism. We've learned to catch lightning and hold antimatter, but you feel it in your breath, the fragility of it all. One broken magnet, one system failure, one lost vacuum seal, and the anti-atom would meet the wall, and the wall would cease to be. Still you feel no fear, just reverence, because science is not reckless. We build layers upon layers of safety, systems that check systems, and minds that imagine disaster, not to summon it, but to prevent it. We build not because we are blind to danger, but because we dream responsibly. Your thoughts drift outward again to the stars, to war, to peace. What if antimatter were used as a weapon? Could someone build a bomb from it? Perhaps someday, but not yet. The energy costs are too great, the containment too delicate. Antimatter for now is safer in theory than in threat, but the possibility is not lost on you. It is written in every physics paper's footnote, every lab's emergency protocol. And so, holding this delicate thing in your mind, you begin to understand, the future is not just about power, it is about trust, in each other, in our systems, in our restraint. Antimatter is not the first peril we've faced, but it may be the most beautiful one. You breathe in, and in that breath you carry the dreams of spacecraft, the precision of magnetic fields, the wonder of symmetric particles, and the caution of quiet minds. You are not afraid, you are awake. And you wonder if matter and antimatter were created together. Where did all the antimatter go? Did it ever have its own universe? Its own stars and galaxies identical, yet mirrored? Could it still be out there, beyond the reach of our telescopes, hiding in the fabric of some distant quadrant of space-time? Or maybe the next chapter begins not with destruction, but with balance. What if we found that balance again? The stars drift slowly past your view. You're curled in a chamber just wide enough for sleep, encased in stillness. No movement, no vibration, only the soft pulse of your own breath, steady, rhythmic, echoing faintly inside your cocoon. Beyond it, the vastness of interstellar space. You are between places no longer tethered to Earth, not yet arrived anywhere else. And as you drift, time itself seems to slow, not in a metaphorical sense, but in a literal one, because this is not an ordinary ship. This is not chemical propulsion, or solar sails, or even the gentle push of an iron engine. This is something rarer, stranger. You're riding on a whisper of annihilation, antimatter. The word alone carries a sort of mystery, a counterpart to everything you know, a shadow twin to the ordinary matter that makes you and Earth and stars. For every electron, there is a positron. For every proton, an antiproton. Mirror opposites, balanced in mass, but reversed in charge. When they meet, when matter and antimatter touch, they do not bounce, they vanish. In that vanishing, in that perfect erasure, an immense burst of energy is released. A conversion so total, so clean, it almost defies belief. In your sleep-bound ship, this reaction is controlled carefully, precisely. Antiprotons stored in magnetic traps, suspended like fireflies inside electromagnetic cages, are released in pinpricks. They collide with waiting particles of ordinary matter, and in a blink, they cease to exist. In their place, energy, pure, radiant energy. That energy becomes thrust, a directed stream of light gamma rays, or particles depending on the engine's design. It is focused, channeled and pushed against space-time itself, nudging your ship forward. And you are not pushed violently. You are not launched with flame and roar. You are nudged, again and again, like ripples catching a leaf. You accelerate slowly, but relentlessly. A journey to Alpha Centauri, the closest star beyond our sun, once seemed a sentence of generations. With conventional rockets, it could take tens of thousands of years. But with antimatter, the story changes. You close your eyes and imagine the numbers. A ship using antimatter propulsion, even with today's projections, could, in theory, reach a tenth of light speed. That's 20 years to Alpha Centauri. 20 years in a sleep like this. In silence, wrapped in the black. But those are conservative dreams. The promise of antimatter is even more radical. Its energy density is staggering, over 90 billion megajoules per gram. That's orders of magnitude greater than any chemical fuel. Even nuclear reactions, fission or fusion, trail far behind. A gram of antimatter, if perfectly annihilated, could launch a small spacecraft to a significant fraction of light speed. 10 grams, 100, and you begin to speak in fractions of a lifetime. The word centuries becomes decades. The word impossible begins to loosen its grip. But there's a catch. Of course there is. Antimatter does not exist freely in the universe. It must be made, and making it is hard. Painfully hard. At facilities like CERN, antiparticles are produced in high-energy collisions, smashing protons together at near light speed to create the faintest glimmer of their counterparts. Once formed, these particles must be isolated immediately, kept away from all matter, or they'll simply vanish in a blaze of energy. The storage is intricate. Magnetic bottles, vacuum chambers, supercooling. You cannot touch antimatter. You cannot hold it. You can only balance it in magnetic tension, like trying to keep a snowflake suspended in the heart of a flame. Yet still, we try. You float in your cocoon, eyes closed, and imagine Earth scientists bent over particle accelerators. Imagine the faint spark of positrons in a trap, like stars in a snow globe. Imagine the first time someone realized that these invisible ghosts could move a ship. The ship around you was built from such dreams, dreams of containment, of direction, of silent travel without wings or sails, of using the cleanest fuel nature can offer, not to burn but to disappear, and in doing so move. And in this movement, you find peace. Because there is no noise, no jolting acceleration, just the tiniest pulse, like a soft exhale. Again and again and again. Outside, you pass Mars, red and desolate, its air thin as whispers, then Saturn encircled in golden rings, majestic and still. Beyond that, the stars thicken. The darkness grows deeper, somehow fuller. You are not just traveling through space. You are slipping through time, through distances once thought sacred. You are held by technology, so delicate it borders on sorcery, and yet grounded in physics as real as gravity. You imagine others, future generations curled like you in cocoons of quiet propulsion, not bound for the moon or Mars, but for the stars. Carried not by rockets but by ideas, by the strange elegance of annihilation. There is something poetic about it, you think, a symmetry. That we move forward by undoing something. By taking two opposites, matter and antimatter, and letting them cancel each other so cleanly, they birth momentum. It is not destruction. It is a kind of unity, a return to stillness, but one that pushes forward. You open your eyes. The stars are closer now. Not visibly, not yet, but you feel it. The same way a seed feels the pull of the sun long before it breaks the soil. Your ship hums with intention, and you, wrapped in its embrace, surrender to the dream again. Because the journey has just begun. Because space is not empty, it is full of stories, and you are now one of them. And ahead, waiting in the ink of night, is the next chapter in your quiet odyssey, where time itself may begin to bend. You drift in stillness, tucked into the curve of night. The stars above you do not flicker. They shimmer, steady and watchful, like lanterns strung across the edge of thought. In this quiet dark, your imagination awakens gently, stretching like a sail catching a soft wind. Somewhere out there, beyond the now, are ships not the kind that sail on water, but those that dream across stars. Starships. Their names hum through your memory: Enterprise, Rocinante, Serenity, Discovery 1. Each a vessel of story, each carrying the human desire to go farther, faster, deeper into the unknown. Tonight you board them not as a passenger of metal and mass, but as a traveler in thought. Let us begin with the warp drive, a whisper from the world of Star Trek. A ship bending space itself, not moving through it, but pulling it closer in front and stretching it behind. Space, like a fabric, folded gently so that two distant points kiss. Could it work? In the soft light of recent science, a concept called the Alcubierre drive flickers, a bubble of space-time around a vessel, shrinking the distance without violating the speed of light. Yet this bubble needs energy beyond imagining, exotic matter we have not yet touched. Still, the math allows it. Like a song you almost remember, it feels familiar but just out of reach. Now shift your gaze, a gentle rotation of the mind, and see the shimmering sails of a photon ship. A light sail, no thicker than a whisper, catching sunlight like wind. It doesn't roar, it glides, pushed by the pressure of light itself. NASA has tried, and the Japanese Ikaros has drifted softly through space with such a sail. And then there is Breakthrough Starshot, an idea to send a tiny craft, driven by lasers from Earth, to Alpha Centauri. A ship no bigger than your palm, racing at 1/5 the speed of light. No crew, no fuel, just the precision of engineering and the quiet push of photons. It's not just fiction, it's a plan. Feel now the hum of engines beneath your feet. Ion drives. Not flashes, not explosions, but a slow, steady push, the breath of ions released into space, like a sigh that never ends. Dawn, the spacecraft used one to explore the asteroid belt. These are engines of patience, no sudden leap, but a gentle drift that gathers speed like a thought over time. You are not thrown through the stars. You are drawn quietly by a thread. Yet your heart still reaches for something louder, the fire and thunder of fusion. A star, captured and contained, turned into thrust. Project Daedalus, imagined decades ago, dreamed of fusing helium-3 and deuterium in great pulses to send a ship to another star. A lightless explosion, aimed backward, pushing the craft forward. We have not yet built it, but we know what it would need. And we know what it would give: speed, endurance, and a chance to leave the sun far behind. And still further out, the minds of scientists and storytellers play with antimatter particles that vanish in a blaze of energy when they meet their twins. It is efficient, beautiful, and dangerous. To carry antimatter is to carry a storm in a bottle. We can make it, but only in pinprick amounts. A gram of antimatter could launch a ship, but we do not yet have the tools to catch such lightning. Pause now. Let the possibilities settle around you like a mist. Each of these ships warp, sail, ion fusion, antimatter lives in a place between fact and fiction. Not pure fantasy, but not yet real. They are sketches on the edge of what we understand, and each sketch is drawn by a hand reaching toward the stars. But why this reaching? Why, night after night, do we dream of flight beyond our sky? Perhaps it is not distance that pulls us, not light years or alien worlds, but the need to keep moving, to keep asking. Each ship is a question: can we? Should we? What might we find? And who might we become? You imagine yourself aboard one, now the hum beneath you, the stars ahead. The ship is quiet, steady and small against the endless dark. And yet you feel immense, not because of what you command, but because of what you are willing to wonder. Every voyage begins not with engines but with curiosity. Before we build, we dream. Before we travel, we imagine. And so you drift again through story, through science, through hope. Around you the starships sail on, some with sails of light, some with coils of plasma, some still only lines on paper. But all of them are real in one way or another, real because we believe in what they might become. In the soft stillness of your breath, you understand we build ships because we are made to explore, to move not only through space but through thought. And perhaps one day when fusion pulses or sails unfurl, we will look back on this quiet dreaming and call it the true beginning. For now you remain still a voyager, not of matter but of wonder. Somewhere ahead, beyond the edge of this chapter, another question awaits. If we ever do reach the stars, how will time itself greet us there? You drift now, gently, no longer flying through impossible tunnels of pure energy or spiraling around annihilation-born suns. Instead, you are suspended in a quiet kind of space, the kind that isn't measured in light years, but in the hush between heartbeats. Was Earth is returning to you, or maybe you are returning to Earth. The two feel the same. The blue and white marble hangs before you, turning slowly in the cradle of black. Home, you recognize the way the oceans breathe, the way the clouds carry secrets, the way sunlight paints mountains gold each morning, though from here it all looks small and silent. You've traveled far not in distance, perhaps, but in thought. Antimatter still hums behind your eyes. It began with opposites. Every particle, you learned, has a mirror not of glass, but of nature. The electron and the positron, the proton and the antiproton. They exist like shadows and flame, born together, vanishing together. And yet from this strange symmetry, our very universe emerged. Why one side outweighed the other remains a riddle one. You carry home like a smooth stone in your palm, warm from the touch. You think about the first moment someone imagined it not with machines, but with mind. A thought that maybe nature plays both sides of the coin, that every something has an unsomething. And you remember how that thought grew into equations, and those equations into collisions, and those collisions into flashes of light and hope. There's poetry in that kind of persistence. Even now, scientists chase the antimatter trail like fireflies in the dark. At CERN beneath the Earth, in tunnels as quiet as cathedral vaults, beams of particles race and crash and vanish. Tiny fireworks that burn no brighter than a single idea. From those vanishing points, knowledge blooms. You close your eyes and see it, an antiproton forged from energy, caught and held in a trap of magnetic hands. It doesn't last, it never does, but for a fraction of time it is. That's enough. Your thoughts drift to stars, those bright archives of time. Antimatter plays a role there too, in ways still veiled. Gamma rays hum across the galaxy, like distant whale song, maybe calling from regions where antimatter lives, or once lived, maybe hiding the tracks of ancient battles between matter and its mirror, or maybe whispering of something stranger, a symmetry too deep to break. On the station your sleep was filled with dreams of propulsion, of ships not pushed by fire, but by annihilation, where a speck of antimatter meets a speck of matter, and together they vanish in a pure burst of energy, so efficient, so intense, it seems unreal. You imagined such a ship sailing past Saturn, past Neptune, out toward the interstellar dark, and yet the fuel is elusive, hiding behind the curtain of cost and containment. You recall the numbers, 1 gram of antimatter enough to level a city, or power a planet, but to make that gram, centuries of current technology, billions in resources, a fragile dream, cradled in magnetic fields and wrapped in the hope of better ways. Still, isn't that the nature of dreams? Even the simplest flower begins as an invisible idea. The same is true for revolutions. They begin in soft thoughts, ones that stretch gently through science classrooms and late-night observatories, ones that ripple outward from questions like, why is there something rather than nothing? What if we could hold the opposite of all we are, and not be destroyed by it, but illuminated? You smile. Not all discoveries have engines. Some have lullabies. You think of Dirac now, the quiet mathematician who first wrote of these mirrored particles, not from experiment, but from symmetry, from beauty. The universe, he said, should be elegant, and so when his equations demanded a new kind of particle, he trusted them. and it turned out to be real. Imagine believing in something because the math felt beautiful, and so the journey home becomes less about bringing answers, and more about carrying that feeling. The feeling that questions are worth their weight in wonder, that science doesn't end in certainty, it opens into it. Beneath you now, Earth turns. You can see the line of dawn curling across the Indian Ocean. Cities blink awake, fields warm. Somewhere someone is looking up at the sky, wondering what's out there. Somewhere else, a child is asking, what happens when opposites meet? You know the answer isn't simple. Sometimes they cancel out in bursts of light and silence. Sometimes they build galaxies, and sometimes they just teach us how to look. The antimatter you studied may never power your car, or cook your food, or launch you to Mars, but it has done something quietly miraculous. It has made your mind larger. It has taught you to stand calmly at the edge of the unknown, and stay, without panic, without haste. You sit in that feeling. It's a gentle thing, this kind of understanding. It doesn't shout. It doesn't promise. It only hums like background radiation, steady, soft everywhere. The kind of knowing that lets you sleep easier, because you don't need to grasp the whole universe to love it. Outside your window, the sky is beginning to pale. Earth's atmosphere so thin, so tender, glows like the skin of a fruit. You are coming back to it, not with answers, but with a deeper capacity for awe. And that, maybe, is the true return. You bring with you the shimmer of antimatter, not in your pockets but in your questions. You bring the patience of the cosmos, the willingness to live without complete understanding, and still be at peace. Soon gravity will tug you downward, machines will whir, hands will welcome you back. But for now, you stay in orbit just a little longer, watching the light bend on the edge of the world, watching the curve of curiosity carry you home. You close your eyes, and for a moment you are both particle and mirror, one who seeks, and one who simply rests. And just before sleep takes you, a new question rises, soft as breath, warm as sunrise. If antimatter is the echo of matter, what then echoes the universe itself?